Hi friends, this video we are going to see how to compute the eigenvalue and eigenvectors of the given matrix. So this is our given matrix A equal to 1, 3, 3, minus 3, minus 5, minus 3, 3, 3 and 1. This is the matrix. So first we require the characteristic polynomial. So we write the. So what is the characteristic polynomial is, we usually denote the characteristic polynomial is P of lambda. This is known as the characteristic polynomial. So the characteristic polynomial is nothing but determinant of A minus lambda I. This is the characteristic polynomial. So usually we will use this formula, but we are going the different way find the characteristic polynomial. We are using the minor methods, that is P of lambda. We are using is, suppose nth order matrix means you take lambda power n minus s1 times lambda power n minus 1 plus s2 times lambda power n minus 2 minus and so on, plus minus 1 whole to the power n sn, where si is the sum of the principal minor minus of order I. Okay, this is the SI formula. So now we are going to see in our problem, and the given matrix is order 3. So our P of lambda becomes P of lambda is lambda power 3 minus s1 lambda square plus s2 times lambda power 1 minus s3. Okay, so now I want to find how to find the s1. S1 means sum of the principal minus order 1. So what will come? These 1 minus 5 1. These are the principal minus of order 1. So you will get it as S1 is 1 minus 5, 1 plus minus 5 plus 1 equal to minus 3. So S1 equal to minus 3. Similarly, we are going to find the S2. So sum of the principal minor order 2 is, we denote as A11 plus determinant of A22 plus determinant of A33. So what is the A11? A11 equal to, so determinant of A1 equal to determinant of, you remove the first row and first column, that minus 5 minus 3, 3 1 second row. So this implies you will get minus 5 plus 9 equal to 4. A22, that is determinant value. So you remove the second row, second column. So that means you are removing this row and second column. So you will get 1 3 3 1 1 3 3 1. So you will get 1 minus 9, you will get it as, you get minus 8. That is 8 to 2 is minus 8. A33. You remove the third row, third column, then you will get the 2 by 2 matrix is 1, 3, minus 3, minus 5. So 1 times minus 5 is minus 5 plus 9. You will get it as, again you will get 4. Then you simply add all the things, that is your S2 becomes 4 minus 8 plus 4. This is nothing but we get 0. Now you go to find what is the S3. S3 means, minor means what will come? Whole matrix determinant of A. So determinant of A is, our matrix is, A is, we are 1, 3, 3, minus 3, minus 5, minus 3. So 1, 3, 3, minus 3, minus 5, minus 3, 3, 3, 1. This is the our matrix A. So I want to going to find the determinant of A. So this is equal to 1 times minus 5 minus 3, 3, 1 minus second. So 3 minus 3 times their cofactor, that is like this k with them minus 3, minus 3, 3, 1 plus 3 times minus 3, minus 5, 3, 3. So you will get the determinant value is now sorry. So you will get that minus 1, this one is 1 times minus 5 plus 9 is, you will get it, the value is 4. You will get 1 times 4, that is we already studied from this one, the same matrix one, same one. Here only we need to calculate, okay. You get the minus 3 plus 9 plus 3 times minus 9 plus 15. So you get the 4 minus 6, this guy is becomes 6, 6 times minus 3 is minus 18 plus 6 times 3 is, again you will get the 80. So this guy is become 4. The determinant of A is 4, that is our S3. So my characteristic polynomial P of lambda equal to, I want to substitute the lambda cube minus S1. S1 is value is I already got. S1 is minus 3. So S1 minus S1 minus S1, so plus 3 times lambda square plus S2. S2 is 0. So 0 times lambda plus minus, you will get the 4. That is our characteristic polynomial. We get, this is our characteristic polynomial. Okay, now I am going to factorize. If you are going to factorize, you will get, so 1 is the one of the root, we know that because we add all the coefficient, we will get 0. So 1 is the coefficient, so 1 is the one of the roots. So now then you can write this one is lambda plus 1 lambda plus 2 the whole square. This is our P of lambda. What is the eigenvalue? Eigenvalue is root of characteristic polynomial. So P of lambda equal to 0. This implies lambda equal to 1 or lambda equal to minus 2. But minus 2 is 2 times repeated. So these three are called the eigenvalue. So eigenvalue of the given matrix is matrix R, because these are 3 will go. So 1, minus 2, comma, minus 2. This is called the eigenvalue. So next step, we are going to see how to find the eigenvector. So eigenvector means, so this is depends on the your eigenvalue. Suppose lambda equal to 1, lambda equal to 1 we are choosing, then you find the matrix A minus lambda I x equal to 0. This x we call as the eigenvector. Okay. So clearly lambda is 1. So A minus I times x equal to 0. So our aim is this matrix, this I want to find the solution of this equation. So we know that this is, I take the matrix B. So Bx equal to 0. What is the meaning? This meaning is, this implies null space of B is the eigenvector. Okay. So eigenvector nothing but you find the eigenvalue, then you get the matrix A minus lambda I. You get the one matrix. That matrix space basis, that is null space basis, that is your eigenvector. So now I find the what is the B matrix. So A matrix you already know. What is the A matrix is 1, 3, 3, minus 3, minus 5, minus 3, 3, 3, 1. Minus lambda, lambda value is 1 only. So you will get it as 1, 0, 0, 0, 1, 0, 0, 0, 0. So this is equal to nothing but this is equal to 0, 3, 3, minus 3, minus 6. This is minus 3, 3, 3, 0. So this is our the matrix B. This is the matrix B. So I want to find the eigenvalue, that is null space of B only I am going to find. Null space of B. So I find the null space of B. Okay. So we already know that how to find the null space in. So we are going to do it here. Okay. So our matrix is B matrix. So I already put the detailed video of how to find the null space of any given matrix. So I will give the description link also. If you want how to find the null space, you can watch it there. So this is our matrix B, 0, 3, minus 3, minus 6, minus 3, 3, 3, 0. So I want to choose the A1 as the pivot position. So but the pivot position must be non-zero, but our accidentally we get the first pivot position is 0. So I want to change the elementary row operation. I want to do it. Okay. So this is the matrix B. So B is equivalent to, I want to convert. I interchange the row, first row into second is become first. So minus 0, 3, 3, 3, 3, 0. That is, I interchange R1 into R2, R2 becomes R1. I interchange the row 1 to row 2, row 2 as row 1. Now I fix it. So pivot position always become 1. So I will divide them minus 3. So 1, 2, 1, 0, 3, 3, 3, 3, 0. So I change R1 becomes R1 divided by minus 3. So next step, I want to so I fix this is my pivot element. So downside of all the elements must be 0. So the second row first column is 0, so I don't bother about it. So third row first column is non-zero, I want to make it. So how I do it? This is, so first row and second row is, I don't want to disturb, 1, 2, 1, 0, 3, 3. So R3 only I want to make it. How I become R3? R3 minus 3 times R1, then it's become 0, correct? 3 minus 6, 3 minus 6 is minus 3, minus 3. So this is my pivot position, first pivot position. The second pivot position is this point. This is non-zero, fine, but it is not a 1. So I will go to divide by 3. So then it's become 1, 2, 1, 0, 1, 1, 0, minus 3, minus 3. Because my aim is I converted the given matrix into row reduced echelon form. So R2 becomes R2 divided by 3. So then this is my pivot position. This is my second pivot. I want downside is become also 0. So this guy is become 1, 2, 1, 0, 1, 1. The third row this guy means 3 times multiply and add it, correct? So it's automatically become last row fully 0. So R3 is R3 plus 3 R2. So this is so my next aim is I want to make this guy also 0. That is my aim. So how I can do it is, so last row as it is, I kept it as it is. I don't want to disturb last row. Second row also I don't want to disturb. The first row is 1. This guy is 0. This guy is become minus 1. That is R1 becomes R1 minus 2 R2. So this is the null space of B, mean this is I take the matrix U1. So null space of B equal to null space of U1. Because we are using the Gauss-Jordan elimination method technique only I am going to use. So it's preserve the null space. So null space of U1, this implies 1, 0, minus 1, 0, 1, 1, 0, 0, 0 times the 3 component x1, x2, x3. equal to 0, 0, 0. Now what will become? So x1 equal to x3, x2 equal to minus x3, x3 is x3. So you write in the vector form now. x1, x2, x3. x3 is the any real number, I take it, then you will get 1, minus 1, 1. This is the eigenvector of the given matrix, the eigenvalue for lambda equal to 1. So this is the eigenvector of A for lambda equal to 1. So not only eigenvector 1, you can find the lambda equal to minus 2 also you have to find. This is the eigenvector for lambda equal to 1. Now you take this is as the value, you can define this name as V1. Now for lambda equal to 2, you are going to find lambda equal to 2. Then the given matrix is A minus A plus 2i will come. This is our matrix. So this is we add it. We will get the value is 3, 3, 3, minus 3, minus 3, minus 3, 3, 3, 3. This is the A plus 2i matrix. Now you take this matrix is some C. Now you are going to face null space of C only is our eigenvector, correct? So that is why similarly I take C equal to, so the given matrix 3, 3, 3, minus 3, minus 3, minus 3, 3, 3, 3. So this is equivalent to, because I want to choose, this is the my pivot position. So 1, 1, 1, the first row is divided by 3, okay, because my pivot position always must be 1, that is my aim. So R1 becomes R1 divided by 3. So next time is I want to make the, these two guys are must be 0. How I can do it? So 3 times multiplied by the R1 plus R2, that is R2 is R2 plus 3 times R1. So it's become 3, 3, 3. So if you add me, you will get the 0, 0, 0. Then R3 is R3 minus 3R1. So then this is everything will become 0. So here, now this is you take the matrix U2, null space of C equal to null space of U2, both are same. So then 1, 1, 1, 0, 0, 0, 0, 0, 0 times x1, x2, x3, 0, 0, 0. This is the null space. I want to find the solution, correct? Null space will come x1 equal to minus x2 minus x3, x2 equal to x2, x3 equal to x3, because here basic variable is only pivot position here only. So basic variable is x1 only the basic variable, x2 and x3 are free variables. So you represent in the matrix vector form x1, x2, x3, you represent x2, x1 is minus 1 times x1, x2 is 1, x2 equal to x2, so 1 times x3 is independent of x2, you write it as 0, plus minus 1 times x3, so you write x3. x3 times minus 1 you will get x2 is independent of x3, x3 equal to x3. So these two are the eigen vectors of the matrix A for lambda equal to 2. So this you taken as a V2, this is the V3. These two are the V2, V3 is the eigenvectors. Eigenvector of matrix A for lambda equal to minus 2 are eigenvectors of minus 1, 1, 0, minus 1, 0, 1. So eigenvalues for lambda equal to 1, you get the eigenvector is 1, minus 1, 1. For lambda equal to minus 2 is minus 1, 1, 0 and minus 1, 0, 1. These are the eigenvectors. So we write the summary or the answer fully answer, we can write it as it is. So lambda eigenvalues of A are 1, minus 2, minus 2. So corresponding eigenvectors are tests are 1, minus 1, 1. This is for eigenvalue 1. For minus 2 is minus 1, 1, 0. This is also another minus 2, minus 1, 0, 1. I hope you can understand how to compute the eigenvalue and eigenvector for the any n by n matrix. Thank you for watching this video.